A first-order differential equation is called separable if it can be written as the derivative of y with respect to x equals a function of x times a function of y. Let's solve an example. The derivative of y with respect to x equals x times y, given that y of 0 equals 3. Step 1. Separate the variables. We move all the y terms to one side and all the x terms to the other side. This gives us 1 divided by y dy equals x dx. Step 2. Integrate both sides. Integrating 1 divided by y dy gives the natural log of the absolute value of y. Integrating x dx gives x squared divided by 2 plus a constant. So we now have the natural log of the absolute value of y equals x squared divided by 2 plus a constant. Step 3. Exponentiate both sides to remove the natural log. After relabelling the constant, this gives us y equals a constant times e to the power of x squared divided by 2. Step 4. Apply the initial condition. We are told that y of 0 equals 3. Substituting x equals 0 into our solution shows that the constant equals 3. So the particular solution is y equals 3 times e to the power of x squared divided by 2. Step 5. Check the answer. We differentiate this solution with respect to x. This gives the derivative of y with respect to x equals 3 times x times e to the power of x squared divided by 2. Notice that this equals x times our original solution for y. So the derivative of y with respect to x does equal x times y, exactly as the original equation required. The solution checks out.